Good afternoon and thanks for tuning in. Today we have Gary Shepson from Carl Zeiss Vision who is going to be presenting on the Zeiss iProfiler and iScription technology. Questions will be answered at the end, and here you are, Gary. Let me just hand the control over to you and then click OK. There we go.
Okay, am I on the screen there?
Yep, I see your screen now.
Okay, we'll get started then. Okay, we're going to talk today about the iScription, which is done through the iProfiler, which is a new piece of equipment available from Carl Zeiss Vision. This can give a whole new standard of care for the doctor and for the patient. This is kind of the next level in examining techniques and as well as being able to produce lenses. First of all, we'll just take a look at how you can unlock your potential through iScription. It is necessary to have the iProfiler equipment to make this happen, but it is very exciting and very interesting new news. First of all, the customized lenses using iScription are all through Zeiss. They need to be the Zeiss customized lenses for this process. It is a patented process. What we're going to talk about today, first of all, is the limitations of the subjective refraction. Talk a little bit about image noise and what that is, the importance of pupil size for image quality and for examining techniques, the iScription process itself, including the iProfiler, the subjective refraction, the iScription calculation, and then lens production. And then we'll talk a little bit about the customized lenses using iScription, how the patient experiences the product process, and then how it can benefit the patient and the practice through increased satisfaction, increased pay, and increased revenue. So first of all, let's just take a look at what we're doing with iScription. When you look at these different scenes here, this is how we normally see. Our life is not in black and white and not in high contrast. Whereas when the examination process is done, the Snellen chart the doctor uses is actually in very high contrast, black and white, high contrast letters, and so it kind of has limitations, and we've been using this for many, many years. Now we can find a way to actually help the patient see in low light conditions and in the grays and rainy conditions and things like that. So the limitations of the subjective refraction would be what the optometrist or ophthalmologist does when they're asking which is better, 1 or 2 with the phoropter. So in the subjective refraction, we're typically in a normal room lighting. Even if it's in dark room lighting, the pupils are still small because of the chart is bright white and has very sharp letters, high contrast letters, and we're not able to, in those circumstances, get the effect of what higher order aberrations are causing. Higher order aberrations are when the eyeball is shaped differently than a sphere. We're not talking cylinder. Sphere and cylinder are what are called lower order aberrations. Higher order is like the lens is not shaped perfectly spherical or aspheric. It's actually more like a potato, which is what most eyes are like because they are a living human being and part. So what we want to deal with is the shape of the eye, and with the iProfiler we're able to actually measure that. Another limitation is that when we do the subjective refraction, we are limited to increments of 0.25 diopters, and because of that we can result in rounding errors. We're going to take a look at what the Jackson cross-cylinder technique is. And the other thing that's limiting is the observation skills have to do with the patient's ability to respond. So we find that repeated measures of these subjective refractions, one exam after another, can differ by more than half a diopter due to all of these things. So let's just take a look here at the Jackson cross-cylinder method. We're going to first of all look at the left side. I'm going to point an arrow to it here. You can see that what we've got here is cylinder, and we have power and axis. If you look at the blue, you can see that there are different colors of blue. This would be the eyeball, and the darkest the blue is, that is where the patient would have the best vision. So let's just do an example here. The doctor starts at point A, as you see on the screen, and asks which is better, 1 or 2. We can see that 2 is in the darker portion of the blue, so the patient would find that better and go to that point then asking which is better, 1 or 2. Again, here the patient would not see a difference. So that then, again, this is very simplified. So then the doctor would go to the cross-cylinder method and start checking the cylinder power. And this would be 1 or 2. You see that 2 is actually right in the very center of the best vision for the patient, so they would pick that spot. Again, the doctor would go 1 or 2. The patient can't see a difference. So the sweet spot then would be there at the point that says C. So that would be a simple lens that just has sphere and cylinder aberration, just the lower order aberrations. Let's look at the next chart over on the right here, and you can see here that there are a couple of spots with darker blue, and it's a very odd shape. That would be more the typical shape of the normal human eye. This is where you've got higher order aberrations. So the doctor in this case then would pick a point, usually from the autorefraction, and go which is better, 1 or 2. You see the patient sees better in the 2, it's in the blue. So they go to that point, which is better, 1 or 2. They don't see a difference. Then we go to the cross cylinder, 1 or 2. 2 is in the darker blue. Go to that point, which is better, 1 or 2. And the patient sees better at 2. So we go to that point. Now here's where it gets tricky. Again, we go which is better, 1 or 2. Now again, they go back to the point we were at before, and that would be what the refraction would be. But as we can see, it is not the perfect spot. The perfect spot is where it's even a darker spot there. And that is what we can do with iScription. We can take, with combining the doctor's subjective refraction as well as the data that we collect on the higher order aberrations, we can use an algorithm and change the prescription to get to the sweetest spot for that patient. So it combines both the doctor's subjective refraction and the information that the iProfiler would give us and be able to get to the spot for that patient, the sweet spot as we call it. So image noise is what's caused by higher order aberrations, and what we see here is distortions that are caused by the visual correction system. And image noise can represent 17 to 20% of the total refractive error. So you can see how this can really make a difference for the patient. It is dramatically influenced by pupil size. So that means that nighttime driving would be especially when the patient would see the difference with iScription. The larger the pupil, the more higher order aberration there is on the eye, which makes a sense when you think about it, that the wider open the pupil is, the more exposure there is to that surface of the eye. And the reduction in image noise is perceived by the patient as better visual clarity. So the larger the pupil in diameter, the more higher order aberrations there are, and so low vision, low light situations, dusk or night driving, is when you can really see the difference. However, this works both for daytime and nighttime, as we have seen sharper color perception that people report with iScription. Point spread function is what this is all dealing with, and when you think, if you think of a star out in the horizon, and the way we look at it and how it can look to us, it can start to spread. We look here at a pupil size of 1 millimeter here up on the upper left, and as the millimeter opens, as the pupil opens, we can see how the spread of that one light can be. That's called point spread function, which is something that is really very much dealt with here with the iProfiler. So what happens with the iScription process then is that we start with the pre-examination. The pre-examination is with the iProfiler. The iProfiler then will measure the image noise distortion in the eye. The iProfiler is a piece of equipment that would be in the pre-exam process. It's a 3-in-1 measurement device that has the Wavefront Aberrometer, a Corneal Topographer, and an Autorefractor all in one. It takes about a minute or less per eye and does all 3 measurements at the same time. With the Aberrometer is a Shack-Hartmann Wavefront Aberrometer, and what this does is measures the higher order aberrations in the eye. This is something that has not been able to be done in the past, and so it's very new technology. The aberrations, as we mentioned, depend on the pupil size. You can see here the total aberrations and then the higher order aberrations during the daytime. And then at night, as the pupil is wider open, you can see there are more or greater aberrations there. This iProfiler also includes a Corneal Topographer, which is nice because then it's all done in the same refractive process or the same pre-exam process. And corneal topography is measuring the topographical map of the cornea. The autorefractor is also included in here. The autorefractor, however, is not used in any of the calculations. The calculations require the doctor's subjective refraction along with the Aberrometer measurements. The autorefraction, though, is one of the most accurate, or is the most accurate autorefractor on the market today, and gives you the sphere, cylinder, axis, and decay readings. So this can really help the doctor, especially to get a beginning point. It is, as I said, the most accurate of all of the autorefractors out there. But again, this is not used in the calculation of the iScription process. So then the second step of the iScription process is the examination and subjective refraction. So this would be the subjective part of it. The iProfiler is objective, just doing all the measurements, and then the doctor is able to check for balance and binocular fusion and things like that that are necessary also for the ocular system. So it's refinement of the binocular vision, and usually the doctor would start with the autorefraction process. So the subjective refraction then use the autorefractor as a beginning, uses the doctor's medical expertise and professional experience, and then achieves the binocular vision balance and tests for other deficiencies in that in the eye with accommodation control as well. So the subjective refraction is the most critical component of the iScription process. It is not replacing this process at all. What we're going to do is refine the process. So the next step then is the iScription calculation and the final RX decision. This is an algorithm that takes the subjective refraction and then the data from the iProfiler and puts that together in order to find that sweet spot or to refine the process. With this algorithm, you can get the best vision for all light conditions, but especially for low light and evening and nighttime driving. What happens then is the iScription it goes down to 0.01 diopters. So it's very, very tightly controlled and is only able to be produced with Zeiss premium customized lenses that are all being done through Soderbergh. And you can see here this on the left, a traditional refraction. This is with a 3mm pupil size. In the right is a 7mm pupil size, and it's optimized for all light conditions. So the final process of the iScription then is the production of the freeform technology. And with this, we're able to minimize the areas across all the surface. This is all done digitally, and we're able to go down to 0.01 diopters. This can be done with any Zeiss progressive, customized progressive, and that would be like the Zeiss Individual, Zeiss GT2 3DV, GT2 3D, and Zeiss GT2 3D Short. And in single vision, there is the Zeiss Individual Single Vision and Zeiss 3D Single Vision. All of these can be done with the iScription process. The benefits to the patient of the iScription is that it gives better vision at night, better contrast, better color perception, and can improvement of up to 20% compared to traditional prescriptions. It also helps the practice because it elevates the patient's experience, differentiates the practice, and it helps to increase the patient's retention as well as profit potential. You can see the two charts on the right here. This was over in Europe, a study that was done before they had iScription and after iScription. They found their revenue, and the average eyeglass sales per month was up 27%, and the average eyeglass sales per month of volume was up 15%. You can see that there were more patients that were retained in the practice because of this process. Another additional revenue for the practice is that from VSP, that there's $25 per exam, 23 of it goes back to the practice from VSP. So there's an additional additional $30 for the iScription lenses on the average. So you can see that there can be a lot of increase of revenue for the practice, and this would be for a VSP patient. For a private pay patient, it can be much greater depending on your scale. So the potential for the office then is the visual benefit, the in-office experience, greater technology, and greater practice revenue and profit for the practice. So I hope you enjoyed this information, and if there are any questions, I'll be glad to take them now.
Perfect. Thank you so much, Gary.
Thank you, Kristen.